Yes, let's start then. In the last session, we covered a topic. Okay, your Seaborn. Okay, Seaborn data visualization using Seaborn. Okay, so in that topic, we basically saw that like whenever we have some kind of data, we're getting some data from somewhere, so we can basically do all the visualizations. Okay, using Matplotlib and Seaborn. So we can make your bar plot, your box plot, your simple line plot, scatter plot, your distribution plot, swarm plot, violin plot, point plot. Okay, so we saw a lot of plots in that. Okay, in those two topics, Matplotlib and Seaborn, we saw a lot of plots. Similarly, class, we saw in pandas how to utilize different methods in pandas to analyze the data. Maybe we can like combine, we can merge, okay, we can drop, we can handle the missing data. Okay, your find na function, your drop na function, your fill na, okay, your split function, your replace function. Okay, a lot of methods we have covered in panda as well. Similarly, we have covered some topic in NumPy also. Similarly, we have covered like earlier we covered some topic in your core Python and advanced Python also. Now, class from today, like starting today, we are going to, like in 2 3 days. Okay, we are going to mix and merge them, merge all the topics to cover a whole project. Okay, we are going to do a project on data analysis, a whole project on data analysis where all the topics that we have covered so far, okay, will be taken care of. Okay, so there is a topic class. There is a topic called as EDA, exploratory data analysis. Exploratory data analysis, I will explain what it is. Okay, like as a name suggests, you can see that when we explore the whole data set, it is called as exploratory data analysis. I will be covering this topic, and along with this, okay, further to this, we will be covering the project also. Okay, so for this particular purpose, I am going to use a particular data set called as Titanic dataset. I showed you earlier also Titanic dataset from the like when we when we loaded it directly from the C1 library, right? SNS dot load underscore dataset. Then we write Titanic. Same thing. I am sharing now a link with all of you where you can download the whole CSV file for it. From this CSV file class, you can download the whole CSV file for the Titanic dataset. Now, this dataset, like this is somewhat different from what we loaded from the internet. Okay, in this case, you can see there is a name file also, name column also present. Okay, and name column, survived column, P class column, your ticket column, okay, your cabin column. A lot of columns are there. Now, in this dataset class, there are some missing data as well. Right, there is some missing data as well. Now, remember that whenever we are working on any kind of missing data, so missing data is also a part of data analysis. It means as a data analyst, it is your responsibility to work on the missing data also based on what kind of data we are getting. Okay, there is like I have shown you multiple ways, okay, for handling the missing data, but to choose like which one of them to choose, okay, how to handle it, okay, how much data do we want to, like suppose we choose to drop the rows or maybe drop the columns from dataset. So it is totally dependent on the type of data that we're getting, length of data that we're getting, sector. Okay, like for example, the dataset is from a healthcare sector or like whichever sector. Okay, how much weightage? I will explain this topic now. How much weightage you are giving to each and every column. That means how much important each and every column of that particular data set is. Suppose there is a Kevin column. In this particular data set that you can see, there is a Kevin column in which there is a lot of missing data. There is a lot of missing data in the Kevin column. Now it is totally up to you class that okay, if you want to drop the Kevin column, okay, now to decide whether to drop to decide whether to drop the Kevin column or not, you have to consider multiple things. Like I told you, first thing that is most important, how much important that particular column is. So in the Kevin column, we saw class that in the Kevin column we are getting DAX, right? In the Kevin column there are DAX. Let me just quickly load it. Okay, here you can see in the Kevin column we are getting DAX, C85, C123, B42, C148. So here you can see that A, B, C, D, E, F, G. From A till G. These values from A till G basically represent the deck on which the person is. The person's cabin is. Okay, and we know that on the ship, the deck of a person is also important. Okay, for the survivability. Why? Because higher the deck. Because higher the deck. Okay, upper the deck. Okay, higher is the possibility of surviving for that person. Okay, so here we can see that Kevin column is important. Now if we drop the Kevin column altogether, that means we are dropping a very important aspect that can help us calculating the survivability. Suppose I am asking you, let me give a very simple relatable example. Suppose we are making a weather prediction system, right? All of us have seen weather prediction system in our phones, right? In our phones you can see that, okay, uh, what weather is there all across the world, okay, at different times also, now also, maybe yesterday also, tomorrow also, even, or one hour after also. If you want to say that, okay, at 8 p.m. today what will the weather at this location, so you can check that too. At least we can get an idea. It is going to be a sunny area, or sunny day, or rainy day, okay, or thunderstorm, or whatever, okay, or like mild rain, okay, or temperature also. So now weather. So when we're calculating the weather of a particular, when we're predicting the weather of a particular area, there are multiple factors on which the weather is dependent on. As simple as temperature of that area. That means how much sun, like how intensity of the sun, you can say. Okay, or cloud coverage maybe. Okay, if clouds are there or not. Okay, how much clouds? If clouds are there, how much clouds? Okay, then your forest coverage area also. That more the forest, okay, higher is the possibility of rain, right? Okay, because we know trees attract rain. Okay, then your humidity of a particular area, okay, population of a particular area, pollution, how much pollution is there. Okay, so a lot of factors are there on which a particular weather is dependent on of a particular area. Now if I discard a single column, let's say I am discarding the temperature column, temperature of that particular area column completely. Okay, that means I am discarding a very important aspect of the data set on which the weather of a particular area depends on. Getting this, class, everyone? Okay, so this is where your importance comes in, that how important that particular column is. Now I can take one more thing, one more column here. Let's say we are talking about salary of different people living in that area, living in that particular area. Okay, in a weather prediction system data, in the weather prediction data set, there is salary also of different people, or maybe average people of people living in that city, possibly. Now your the salary of the people living in any area is not going to affect the weather very much. Obviously it is going to affect. Okay, higher the salary, okay, means they are having cars and all. Okay, and cars and all, or maybe industries and all are there, maybe. Okay, that means that higher pollution is there, and that pollution is going to affect the weather. Okay, so there are some variables, because there are some variables which are directly impacting the output, which are indirectly impacting the output, such as salary column. Now we know that salary is going to affect the weather of a particular area, but not by a very large factor. Okay, it is going to be a very small factor. Okay, for calculating the weather of a particular area. So in this case, we can drop the column. We can drop the whole column. We can delete the whole column. Okay, if there is a lot of missing data in that column. Okay, so here you can see the importance. First thing we saw, right? So now coming back to class EDA. Okay, I'm going to link this with EDA. In EDA, we this is the main thing that we do. Okay, we calculate the importance of each and every column. Now, whenever we are working on data science, okay, so there are multiple steps involved. Okay. Now, in data science also and in data analysis also, the most crucial step, the first step and the most crucial step that needs to be done is your feature engineering. Is your feature engineering. Now, what is feature engineering class? Feature engineering is the process of using domain knowledge, okay, to extract features from raw data using domain knowledge. We have to have domain knowledge. Okay, domain knowledge is, suppose I'm working on, let's say, cancer data set. Okay, and I don't have any knowledge about cancer. Okay, what kind of cancers are there? What are the probable reasons? Okay, or what exactly happens in cancer? Okay, or how do people die? Okay, or whatever. Okay, whatever things are there, I don't know anything about cancer. Okay, so I won't be able to work on that particular, I won't be able to analyze the data. Okay, so I need to have the domain knowledge in that particular, I need to have knowledge about that domain. Okay, so feature engineering is a process of using domain knowledge to extract features from raw data. Okay, now what is a feature? Feature is a property shared by independent units on which analysis or prediction is to be done. A feature is a property shared by independent units on which analysis or prediction to be done. What is the meaning of this? That whenever we are predicting something or whenever we are analyzing something, so there will be a particular property. Okay, like for example, in the case of Titanic dataset, you can see that this survived column is going to be your outcome column on the base, like which we are going to analyze. At what is like we're going to analyze or predict. Okay, suppose I want to see that okay, uh, which type of people survived more. Okay, maybe males survived more, maybe females survived more. Okay, or maybe younger people have survived more on the Titanic, or maybe the people who boarded the ship from S location, they survived more, or maybe the upper class people survived more. Okay, these are basically assumptions. Okay, but if you have to make sure that these things happened on that ship, okay, we have to analyze the whole data set on the basis of which we are going to check the survivability of a person, whether the person survived, what is the possibility of the person surviving. We are going to check that. So that is your feature class. That is your feature. Feature is basically the columns on which this survived column is dependent on. The columns on which this survived column is dependent on are called features. Okay. Then features are used by predictive models and influence results. Okay, now let us understand class what is EDA. Okay, EDA in Python is the first step. Okay, EDA in Python is the first step in your data analysis process developed by John Tukey in 1970s. In statistics, EDA is an approach to analyze data sets to summarize data sets to summarize their main characteristics, often with visual methods. By the name itself, we can get to know that it is a step in which we need to explore the data set. Okay. Now let us understand this whole thing by an example. Okay. For example, you are planning to go on a trip to the X location. to an X location. That X location can be anywhere. Okay, can be anywhere. Things you do before taking a decision. Okay, basically here what we are doing, that where we are planning to go is the output. Where we are planning to go is the output. Okay, and that output is dependent on multiple things. Okay, like suppose you're planning a trip, so obviously you have to take a decision, right? That okay, suppose you want to go to maybe Bombay, okay, or maybe somewhere in Chennai, maybe, or let's say Trivandrum, okay, or maybe Delhi, okay, or maybe Shimla, okay, or maybe somewhere in Seven Sisters, okay, or wherever you want to go. Okay, now where you go, okay, you are going to decide that location on the basis of multiple factors. It is your, like, you will explore the location on what all places are there, waterfalls, trekking, beaches, restaurants, what all are there. Okay, and you're going to study this on Google, Instagram, Facebook, and other social media websites, right? First thing. Okay. Second thing, you will calculate whether it is in your budget or not. Okay. Okay, you will calculate whether it is in your budget or not. Then you will see that how much time do you have. Suppose you want to go for a trip for 4 days. So you will see that whichever location you are going to, if that particular location is like, will you be able to cover majority of the places at least, okay, within 4 days or not? You have to consider the travel time also. Okay, and type of travel, you're going by a train or maybe flight, okay, or by a car. Okay, so it depends on that too. Okay, then similarly, when you're trying to build a machine learning model, read this. Read this line, class, that I have last line. See what it is saying. Similarly, when you're trying to make a ML machine learning model, you need to be pretty sure whether your data is making sense or not. The main aim of the EDA is to obtain confidence in your data set to an extent where you're ready to engage a machine learning algorithm. Okay, so that is your class EDA. Read this once from here till here. I will explain them. Read this class, everyone. Okay, so let's continue class. Okay, so what it is saying, EDA is a crucial step before you jump to machine learning or modeling of your data. By doing this, you can get to know sorry. Okay, so by doing this, you can get to know that it is a step in which we need to explore the. By doing this, we can get to know whether the selected features are good enough to model or not. Are all the features even required? Okay, are there any correlations based on which we can either go back to the data pre-processing step or move on to modeling? So what is the meaning of this class? What is the meaning of this particularly? Okay, what is the meaning of correlations? Correlations means, like, suppose you have a column called as a, let's say, weather predicting system. So in that you have a column called as, let's say, humidity. Okay, humidity in a particular area. Okay, you have another column called as, let's say, amount of rain. Okay, now we all know class. Now we all know that amount of rain is directly proportional to humidity. Higher the rain in an area, higher the humidity will be. Okay, obviously they are dependent. Okay, your humidity column is dependent on the rain column also. So in this case, that there is a relation between these two columns. Okay, and this is called as correlation. Whenever there is relation between two or three or more columns, okay, when the columns are dependent on each other, then they are called as correlation. So are there any correlations based on which either we can go back to the data pre-processing step or move on to modeling? So we have to decide that, okay, through EDA only. Let's continue. Once EDA is complete and insights are drawn, okay, so its feature can be used for supervised and unsupervised machine learning model. So supervised in class, you're supervised, and unsupervised are basically two types of machine learning models. Okay, in every machine learning workflow, the last step is reporting or providing the insights to the stakeholders. And as a data scientist, you can explain every bit of code, but you need to keep in mind the audience. Okay, by completing the EDA, you will have many plots, heat maps. We saw how to plot heat maps, sequential distribution graphs, correlation metrics. Okay, along with the hypothesis by which any individual can understand what your data is all about and what insights you got from exploring your data set. Now, what is the meaning of plus hypothesis? What is the meaning of hypothesis? I'm right. I'm going to, like, just give me a minute. Your hypothesis is, okay. I mentioned here on the chat the whole definition. Hypothesis is a supposition, okay, or proposed explanation made on the basis of limited evidence as a starting point for further investigation. Suppose, like, I am saying that the temperature of a particular area is going to affect the weather. Okay, now this is a hypothesis. I am not sure about it. I am not sure about it, but based on my past experience, my past domain knowledge, okay, I am assuming, I am supposing, see, supposition, na? I am supposing, I am assuming, okay, I am making an assumption, okay, that yes, possibly your temperature is going to affect the weather. Okay, class. So that is your hypothesis. Okay, now let's continue. Along with the hypothesis by which many individuals can understand what your data is all about and what insights you got from exploring your data set. Okay. The next is the class. In our trip example, we do all the exploration of the selected place based on which we will get the confidence to plan the trip. Okay, and even share with our friends the insights we got regarding the place so that they can also join. So it is mentioned here, na, see. As a data scientist, you can explain every bit of code, but you need to keep in mind the audience also. Obviously, I'm not going. Suppose I'm working in a company, okay, and suppose let's say I'm working in some e-commerce company, okay, any e-commerce company, and I'm, let's say, Amazon or Flipkart maybe, okay, and there is some, let's say, festival coming up. Okay, let's say there is a festival coming up of maybe let's say Diwali. Okay, let's say. So in case of Diwali, obviously on Amazon and Flipkart there will be sale, right? There will be sale on Amazon and Flipkart during Diwali. Now I have to decide, class, as a data scientist. It is, I can write the whole code. I can do the analysis that, okay, uh, on which particular commodity, okay, should I give how much discount, okay, how much discount on maybe clothes, how much discount on maybe gadgets, okay, how much discount on electronics, how much discount on maybe like multiple things. Okay, that is something that I have to decide. Okay, that is something that I have to decide from my end. Okay, as a data analyst, that I have to decide. Now I can write the whole code. I can do the whole analysis. I can do the predictions also, whatever. Okay, and I can share the code. Okay, with the sales team also. I can share the code with the sales team also. I can share the code with the marketing team also. Okay, but think about this. Like, are they going to? Will they be able to understand the code? No, right? Okay, your sales team and marketing team being from a non-technical domain, they won't be able to understand the code at all, or whatever is happening in the code. Okay, so that is what here it is mentioned, that as a data scientist, it is my responsibility to keep in mind the audience. I have to prepare a report. I have to prepare my analysis. I have to prepare my like mention my insights in the report in such a manner, okay, that whoever reads the report will be able, be it a technical person, be it a non-technical person, they can understand the report completely. I have to write the report in their language. Okay, I have to. This is where your data visualization comes in. Okay, that is why graphs are very much important, because sales team and marketing team, okay, they are dependent on graphs. Okay, on the basis of that, they are going to take decisions. Okay, so I have to make a lot of graphs, okay, representing multiple things, okay, to support my arguments. Okay, if I say that, okay, that people in the age group of maybe, let's say, 18 to 30 are going to purchase gadgets more, okay, in this particular, in some particular location. So obviously in that particular location, I am going to give more ads. I am going to give more ads of gadgets, right? For example, let's say I will say the people of Delhi, okay, people living in Delhi are going to purchase more gadgets during Diwali. Okay, this is my prediction. Okay, so obviously I will give more discount also, okay, and to encourage them, and I will, okay, and I will run ads also. I will run ads or advertisements also in like multiple like places in Delhi. Okay, maybe newspaper advertisements, okay, or maybe advertisement on maybe games and all, okay, or Google ads, like all of you know, okay, about ads, right? TV ads maybe. Okay, so I will show ads, okay, to Delhi location, to Delhi people, basically location based ads. Suppose I see that, okay, the people of let's say Hyderabad are going to purchase clothes more during Diwali. Clothes, okay, they are going to purchase clothes more as compared to people of Delhi. So I will run, okay, ads of, let's say, I will spend 2 lakh rupees. 2 lakh is very small amount, but still, okay, I'm giving an example here. Okay, I will spend 2 lakh rupees on ads in Hyderabad, okay, and I will spend only 1 lakh rupees in Delhi, okay, on clothes alone, advertisement of clothes alone. Okay, so this is how we decide. Okay, so if you're giving this ideas, okay, if you're giving this analysis, okay, all this analysis, we have to take care of the audience also. So class, EDA is a phenomena under the data analysis used for gaining a better understanding of data. Aspects like main features of data, variables and relationships that hold between them. Okay, identifying which variables are important for our all. Okay. Now steps in EDA. Steps in EDA is basically your first is your description of data. First we have to describe. Okay, that what kind of data do we have? Then so description can be done normally also, like you can run queries, filtering, your describe method, okay, your count method, your mean, median, mode, standard deviation, your cumulative sum, cumulative product, okay, your absolute value. Okay, so there are multiple methods that we know to describe data. That is one way. Second is your handling in description of data. Second is your data visualization steps. Okay, whenever we have some numerical features, okay, so it is better to show them using graphs and plots, histogram, bar plots, scatter plots. Okay, it is important. It is better to store this kind of information, numerical information, in terms of graphs and plots. Categorical data, it is better to like show insights of them. Next is class handling missing data, handling imbalanced data, handling outliers. Outliers I explained you right in the last session. Okay, outliers are understanding relationships between the data through plots. Okay, and then data cleaning if required. So this is class, this is the whole data analysis that we need to do. The idea is to convert raw data into useful data on which we can apply machine learning later on if we want to, or we can simply do analysis. That's it. So this is your EDA. Now procedure for analysis, acquire domain knowledge. First step is acquiring domain knowledge, then making some assumptions and observations, giving hypothesis. Okay, checking those hypotheses and assumptions and observations by visualization tools. Okay, and then give inferences and draw conclusions. Okay, and then hypothesis testing. Okay, this is basically your in this visualization, inferences and conclusion, we basically test the hypothesis that we have given. That suppose I am assuming that okay, your temp again same example, temperature is important. Okay, now I have to test this whether the assumption that I have taken, if that is correct or not, if that is even correct or not. The class for this particular purpose, now we are going to use Titanium dataset. So all of you do one thing, open this particular link. Go to Google and mention kaggle.com/Titanic/data. Okay, I shared this link with you earlier also. Okay, when I showed you that the whole data set in the earlier classes, in the previous class, I guess, previous to previous class. Okay, let me open this from my end. Open the class, open the link class, everyone in your system. This link, kaggle.com/c/Titanic/ let me share this link on chat also. Okay. So class, you have already downloaded the Titanium dataset. I shared the link earlier. Okay. Titanium dataset you have already downloaded, all of you. Let import this packages first. Is done. We'll read the Titanic file. So wait a second. File is not there. Series. See here you can see guys, the whole data set, the whole file is written here. See. Okay, class, now do one thing. I'm giving you one task now. Okay, see the first step here that we need to do is you're acquiring domain knowledge. Now I've shared one link right on the chat. Okay, a Kaggle link I have shared with all of you. Open that link. In the link now there you will see an option of overview and data. In the top you will see an option of overview and data. So read the whole overview. Read okay read the challenge basically in the overview. Read what the challenge is all about in the overview. Okay, and in the data, read the data dictionary. In the data, read the data dictionary, what the data is all about. Okay, your variable notes also. Okay, and study the data set. Okay, I've already done this previously also in the class, so all of you should know how to do it. Open the link, take maybe how much time? It is 7:19 now. Maybe take time till 25. Okay, and do this now. Everyone. If you have any doubt, please ask. I'm here only. Just but study that link completely. Okay, so let's do one thing, class. Hello. Okay, do one thing. Let's do one thing. Okay, it is already 8:27, 7:27. Sorry. Okay, so we are going to take it till here only today. Do one. Okay, I'm giving one homework to all of you in today's session. The link that I have shared with you, class, Kaggle link. What you need to do, you need to go to the overview data. Okay, you need to go to your go to your code link. Okay, you need to in the code now you will see a lot of information, a lot of codes uploaded by a lot of people. Okay, so open them separately. Okay, open them randomly, not all of them. Okay, totally up to you. Okay, open them randomly and see what other people have done on this particular data set. Okay, in all a lot of them you will find, like for example here, if you scroll down, you'll find EDA on the Titanium data set. Okay, somewhere you will find that, okay, absolute beginner step by step part 1 hyphen ADA. Okay, so a lot of people have uploaded their files. I'm naming the file names. Okay, so you need to open the files, okay, and study the EDA that been done by the people, other different people. Okay, because see, EDA, it is not necessary that everyone, each and every data analyst is going to do the same EDA. Okay, and they are going to select the same features. In yes, most of the cases it should be same. Okay, but it is not necessary that they are going to be completely same. So that is what you need to study, class. Study the data set and okay, take out important information from all of them. Okay, so overview, data, code. This first three tabs you have to study in this Kaggle link. Okay, by tomorrow. Make sure of this, everyone. Okay. So yeah, that is all for today then, class. Okay, that is all from today from my end. You will learn a lot in this thing. When you do study, we learn a lot. Okay, everyone. Thank you.